Hello, my name is Pratish Vakor, a postdoctoral researcher at the University of Nevada, Reno School of Medicine, and I'll be discussing our recent findings relating to how lysosomes regulate calcium spark activity in vascular smooth muscle cells. So what are calcium sparks? These are localized rapid rises in intracellular calcium that are present within vascular smooth muscle cells. Calcium sparks are generated by the opening of ryanodine type 2 receptors located on the intracellular calcium store of cells. A calcium spark can activate plasma membrane-bound large conductance calcium-activated potassium channels, or BK channels. These channels cause potassium ions to leave the cell, resulting in membrane hyperpolarization and smooth muscle relaxation. This is an essential negative feedback pathway that regulates the diameter of arteries and is critical in maintaining systemic blood pressure. Traditionally, it's believed that these calcium sparks occur spontaneously. However, in this study, we show that these are not spontaneous events, but are generated by lysosomes. Lysosomes are involved in a number of cellular processes, such as endocytosis and autophagy. Previous studies have shown that lysosomes are highly mobile and dynamic. However, an interesting and unexpected finding in our study is that lysosomes were essentially stationary and do not move around in freshly isolated vascular smooth muscle cells. We found that using nanoscale super-resolution microscopy, a large number of ryanodine type 2 receptors are located within 40 nanometers of lysosomes. Ryanodine type 2 receptors are activated by calcium through a process known as calcium-induced calcium release, and we know that lysosomes are a major store of intracellular calcium.
So hi, my name's Keevan Griffin and I'm a postdoctoral researcher at the University of Nevada, Reno in the School of Medicine. So transient potential mucoleptin-1 channels, or TRPML1 channels, are calcium-permeable ion channels that are bound to the membrane of lysosomes. And we predicted that calcium release from these channels could activate ryanodine receptors and initiate calcium sparks. We found that TRPML1 channels are expressed on the majority of lysosomes, and they also co-localize with ryanodine receptors. Using genetically modified mice lacking functional TRPML1 channels, we found that isolated vascular smooth muscle cells from these mice displayed no calcium spark activity and the associated BK channel activity. So due to the loss of this negative feedback pathway, arteries from these mice have an exaggerated hypercontractile response to various constricting stimuli. Additionally, we found that TRPML1 knockout mice are spontaneously hypertensive. In this study, we have found a novel and unexpected role for lysosomal TRPML1 channels in initiating calcium sparks in vascular smooth muscle cells. These channels regulate blood vessel contractility and systemic blood pressure. Going forward, it will be interesting to investigate what molecular mechanisms facilitate lysosomes to be stationary in smooth muscle cells, but not other cell types, and also what mechanisms regulate and activate TRPML1 channels. Thank you for taking the time to learn about our work.